Hello, students. Welcome back to your geography class. I am Ms. Jenny Shah, and we are doing the chapter Climate. Understanding that we have come back after a break, I would like to do a quick revision just before we jump into the chapter all over again. I hope you all had a very safe Diwali and enjoyed yourselves. Looking forward to meet you all very soon. Praying we get over the pandemic safely and come out with better lifestyles so that we can be in alignment with nature. All right. So, in this chapter, we started understanding the difference between climate and weather. And then we spoke about the climate of India and how we have a monsoon type of climate. Then we pondered about the fact, about the difference between day and night in two different parts of the country. Then we looked at the variations in weather in different parts of the country. Then we had learned about the climatic controls, the six major climatic controls, that was latitude, altitude, pressure and wind system, distance from the sea, ocean currents, and relief features. These are the six major variables that control the climatic conditions or that affect the climatic conditions of any place. After this, we spoke about the factors that affect the climatic condition of India. In that, we learned about the latitude, altitude, pressure, and winds. Uh, then we learned about the Coriolis force, that was an apparent force that is caused by the Earth's rotation. This force is responsible for deflecting winds towards the right in the northern hemisphere and towards the left in the southern hemisphere. And this is also known as Ferrel's law. And then we spoke about the western cyclonic disturbances, okay, which is a weather phenomena of the winter months, which is brought in by the westerly flow from the Mediterranean region. It usually influences the weather of the north and northwestern regions of India. Tropical cyclones occur during the monsoon. They also occur in October and November, and they are a part of the easterly flow. These disturbances have affected the coastal areas of our country, and I had asked you all to find out about any disasters that these western cyclonic disturbances caused to Orissa. Okay, so moving further, today now we are going to learn about the Indian monsoon. Today now we are going to learn about the Indian monsoon. Now the climate of India is strongly influenced by monsoon winds. The sailors who came to India in the historic times were one of the first to have noticed this phenomena of monsoon. They benefited from the reversal of the wind system because they came by sailing ships and they came on at the mercy of the wind. The Arabs, who also came to India as traders, had named this seasonal reversal of the wind system as monsoon. Okay, so monsoon has been influencing Indian climate for a very long time. And early in the historic times, when the sailor used to come to India, they used to witness this phenomena, that was the reversal of the wind system. Okay, and it used to benefit them a lot. So they named this phenomena as monsoon. This is a map which shows the atmospheric condition over the Indian subcontinent in the month of January. So if you see in January, the winds are flowing towards the west. And now this is the atmospheric conditions over the Indian subcontinent in the month of June. Like you can see, there's a reversal of wind from January to June. You can see there's a big reversal of wind which is taking place. Now the winds are flowing towards the northeastern side. So the monsoons are experienced in the tropical area between 20 degrees north and 20 degrees south. Now we will try to understand the mechanism of monsoons, and for that we need to understand some facts. Number one, the difference in the heating and cooling of land and water. The difference is in the heating and cooling of land and water. It creates low pressure area on the landmass of India, while the seas around experience a comparatively high pressure. Okay, so what happens is on the land there is low pressure and on the sea there is high pressure. Number two, the shift of the position of intertropical convergence zone, ITCZ. The shift of the position of ITCZ in summer over the Ganga plain, okay, is also another factor. So basically, this is the equatorial trough, normally positioned about 5 degrees north of the equator. It is also known as monsoon trough during the monsoon season. Number three, the presence of the high pressure area, that is the east of Madagascar, that is approximately 20 degrees south over the Indian Ocean. So there's a very high pressure area over there. And the intensity and the position of this high pressure area, it affects the Indian monsoon. Then so the ITCZ, it is a broad trough of low pressure in the equatorial latitude. This is where the northeast and the southeast trade winds they converge. This convergence zone lies more or less parallel to the equator, but it moves north or south with the apparent movement of the sun. Okay, so this is the intertropical convergence zone. Okay, so as and when this position, this ITCZ position changes, it also affects the monsoon season. The number three was the presence of the high pressure area, that is to the east of Madagascar. The number four is the Tibetan Plateau, which gets intensely heated during the summer, and this results in strong vertical air currents and the formation of low pressure over the plateau at about 9 kilometers sea level. So because of this plateau which gets intensely heated, we get strong vertical air currents, and then there's a formation of low pressure over the plateau that is approximately 9 kilometers above sea level. Then the movement of the westerly jet streams to the north of Himalayas and the presence of tropical easterly jet stream over the Indian peninsula during summer. These are basically the facts, okay, that help us understand the mechanism of the monsoons. So though the basic physics of monsoon, which was described more than 300 years ago, okay, uh, remains the same, its entire mechanism or its behavior is not fully and finally known. Many of its aspects are still being researched. Recent studies have shown that the position of the monsoon is affected by the shifting of the thermal equator and the ITCZ, intertropical convergence zone, as well as by the changes in the position of the jet streams. In summer, the low pressure ITCZ shifts northwards. A low pressure belt gets fully established and it extends from Kutch to the head of Bay of Bengal across the Indo-Gangetic plains. This trough of low pressure is known or is also referred to as the monsoon trough. Okay, this happens in summer, that is around May. By June, this monsoon trough becomes so intense that it attracts the trade winds of the southern hemisphere into India. As soon as these winds cross the equator, their direction is changed and they reach India at the southwest monsoon winds. Even though the Indian monsoon is seasonally predictable, the duration and the amount of monsoonal winds and rain vary from summer to summer. So, apart from these facts that we have told you, it is also noticed that the changes in the pressure conditions over the southern oceans also affect the monsoons. Normally, when the tropical eastern South Pacific Ocean experiences high pressure, the tropical eastern Indian Ocean experiences low pressure. But in some years, there is a reversal in the pressure conditions, and the eastern Pacific has lower pressure in comparison to the eastern Indian Ocean. This periodic change in pressure condition is known as the southern oscillation. Okay, so this periodic change in the pressure condition is known as southern oscillation or SO. So what is this southern oscillation? Basically, it is a seesaw pattern of pressure changes which are often observed between Indian Ocean and Pacific Ocean. If the pressure over the monsoonal area is low, it is considered favorable for better monsoon rainfall. A measure of the monsoon low pressure area in the Southern Oscillation Index. So, how do we measure it? We measure it with the Southern Oscillation Index. The intensity of SOI is measured by Tahiti in French Polynesia, in South Central Pacific and Darwin in North Australia, which represents the northern parts of the Indian Ocean. If the SOI is positive, that is, the low pressure over the Indian Ocean is below normal, it is conducive for a good monsoon. A negative value of SOI implies highest pressure over North Indian Ocean. So it results in poor monsoon rains in India. So if the SOI is positive, that means we are going to get good monsoon, we are going to get good rainy season. But if we get a negative SOI, it means we are going to get a poor monsoon. Now, during the cold weather season, the northeastern trade winds cause rainfall on the Tamil Nadu coast, and the Mediterranean depressions cause winter rainfalls in the northern plains. Now, like I told you that SIO is measured by Tahiti. in French Polynesia, in South Central Pacific, and Darwin. So the difference in the pressure over Tahiti in Pacific Ocean and Darwin in northern Australia of Indian Ocean is predicted the intensity of monsoons. So the difference between these two SIOs predicts the intensity of the monsoons. If the pressures, if the pressure differences are negative, it means we get below average or we get late monsoons. Okay, and if it is positive, that means we get good monsoons. Now, El Nino is a narrow current of warm water which appears off the coast of Peru in the month of December. It is a temporary replacement of the cold Peru current, which normally flows along the coast. Sometimes, sometimes this current is more intense than usual and it increases the temperature by 3 degrees to 4 degrees. The increase in temperature now creates low pressure over the eastern Pacific Ocean. The pressure begins to rise over Australia and Indonesia, and these global changes in weather conditions can lead to a total failure of monsoon rains over India. So we have learnt about two other things, that is Southern Oscillation and Indian monsoon and ENSO. ENSO is El Nino and SO is Southern Oscillation. So this is Southern Oscillation, which I've told you. It's a seesaw pattern of pressure changes, which is generally observed between Indian Ocean and Pacific Ocean. Indian Ocean and Pacific Ocean, yes. Normally, the trade winds and strong equatorial currents flow towards the west. At the same time, an intense Peruvian current causes upswelling of cold water along the west coast of South America. So if there's this seesaw pattern, that means sometimes Indian Ocean has high pressure, then Pacific has low pressure, then sometimes Pacific has high pressure, then Indian Ocean has low pressure, and the winds, they keep doing a seesaw pattern. This is known as Southern Oscillation. Now, effects of El Nino. Now, El Nino is a name given to the periodic development. That means it's not always, it happens periodically. A warm current along the coast of Peru. Along the coast of Peru, a warm current is formed. Okay, it is a narrow current of warm water, and this appears off the coast of Peru in the month of December. Okay, now what happens is it replaces uh, it is a replacement of the cold Peruvian current. So El Nino is a Spanish word which means the child, and it refers to baby Christ. As this current starts flowing during Christmas, so its name is El Nino, which means uh, the child, and it actually refers to the baby Christ. The presence of El Nino, it leads to an increase in sea surface temperatures. Now remember, El Nino is a warm current. So because of it is a warm current, the sea surface temperatures increase and the weakening of the trade winds in the region. It results in the weakening of the trade winds in the region. Okay, so we have learned today the 5 facts that we need to understand, 5 facts that are important to the mechanism of monsoon. Number 1 was the differential heating and cooling of land and water, which creates low pressure area and high pressure areas. Number 2 was the shift in the position of ITC Z, that is Intertropical Convergence Zone. Then number 3 was the high pressure area to the east of Madagascar, okay, which again creates a high pressure area and it affects the monsoon. Number 4 was the Tibetan Plateau. So these are the five facts or the factors that affect the Indian monsoon. Uh, so number 4 was the Tibetan Plateau, which becomes very hot during summer, and it again creates a low pressure area over the plateau. And the last one is the movement of the westerly jet to the north of Himalayas and tropical easterly jet stream over the Indian peninsula. Okay. Then, besides all this, we also spoke about the southern oscillation. Okay. The periodic change in the pressure condition is known as southern oscillation or SO. And then we spoke about El Nino, okay, which is a phenomena where there's a warm current that flows past the Peruvian coast, that is near Peru, okay, and it happens every 2 to 5 years. And the changes in the pressure conditions are connected to El Nino, and so this phenomena is often referred to as ENSO, ENSO. EN is El Nino, SO is Southern Oscillation. Okay. So with this, I end today's class. Go through this much part of your chapters again so that you know your facts correctly. Stay home, stay safe, take care, keep learning. Thank you.